Hello everyone, my name is Muaz Ahmed and I am a data scientist at Royal Cyber. And today the agenda of this webinar is to actually allow you to build and understand how to actually create AI agents within Databricks. So we will be exploring how the platform of Databricks is actually helping us to not only create high level data volume, high volumes of data, the data warehouses, data engineering, and how it has evolved to integrate MLflow AI and now the agentic system as well. And since the agents, AI agents are very hot in demand these days, so I think it will be a very fruitful webinar for you all. So if we talk about the agenda for this webinar, we have a use case where we are actually analyzing the network analysis so that we can experiment with the SOC attacks that a cybersecurity and or an SOC analyst has to face within his integration, within his data pipelines or in his AI models. So let's, without any further ado, let's start with the overall agenda for this presentation. Moving on to the next slide. So before announcing any further, let us go to the presenters. The presenters for this slide are Mohammad Tayyab and Zishan Arif, but unfortunately Zishan couldn't make it due to some technical difficulties. So I'm Muaz Ahmed and I will be the one presenting to you the entire details for this presentation. And for the Royal Cyber itself, Royal Cyber is a series provider and a partner with when it comes to Databricks. We provide services to our clients, whether it be data engineering services, AI or ML services, generative AI services, and agentic AI as well. So Royal Cyber has been in the market for over 20 plus years, and we have our offices in over 5 continents. We provide both offshore and onshore capabilities to not only for project-based resources, but also for long-term resources and resource management. So Royal Cyber has been working in close proximity with Databricks specifically and with Databricks projects. And these data, we have seen the platform grow and evolve, and our clients have been have been finding it very fruitful for them as well. And they have utilized the platform from a point where it was just a data warehousing platform to the kind of beast that it has become today. So moving on to the next slide, if we talk about the overall presentation, so this is how we are going to set the premise. This is how we are going to talk about the agenda and how the overall implementation is being done. So what is basically an SOC, right? SOC analyst. So we have, let's suppose we have a random pipeline out there that is in prod. And for this pipeline, it has been implemented by a number of people who are data engineers, data scientists, and so on and so forth. But if this pipeline gets triggered to some sort of network security attacks or cyber attacks, that pipeline will always cause concern for the SOC analyst. The purpose of an SOC analyst, or which is like security of operational center analyst, is to find out these attacks and to make sure that there are no cyber crime attacks or DDoS or network logging attacks or injection attacks in our pipeline. So the things which make all this very complex for SOC analysts is that in the modern times there are a lot of agents that are being constantly created, and we see a trend. There is a term that is known as vibe coding. We see developers constantly using AI, and of course for the good part of it, that is of course making a lot of wrappers and making their word comfortable. We are actually downscaling the work of 3 or 4 developers to a single developer, maybe with the assistant of AI. And specifically with the introduction of now AI IDEs that include Cursor and Cloud Code, and we all might have some sort of interaction with them here and now. So with the introduction of these IDEs as well, we see that our code base is being entirely dependent on AI. And as specifically for someone who has had to lead the people of the junior resources out there who are actually doing relying quite a lot on AI, they have been, categorized into a term named as vibe coders. So vibe coding is what you basically do is a certain example is you take questions or you ask AI to create a certain code base for you, right? And you get the and let's suppose if you run that code base and you get the errors, right? So instead of trying to figure out the errors, the first issue is that they did not even bother to look at the code base itself. And the next problem is that the error they face, and if a certain IDE or a certain agent is not able to handle those errors, what they do is that they copy paste the entire thing to the next AI, and so on and so forth. So because of that, the wrappers of the agents that are created or deployed, the attack to those agents become very critical, and it becomes relatively easier to attack those agents. The reason being, since we have like a vibe coder hasn't implemented security level or authorization level implementation, and he has just copy pasted it, and let's suppose if his senior has approved it and pushed it to the prod, that could be disastrous for the enterprises. So that is why we have chosen this use case, because in the modern time we feel like this is something that is going to push cybersecurity to quite a lot of quite a higher level. And the reason being is obviously with the increase in the vibe coding, the cybersecurity analysts or SOC analysts have to be more careful about the threats that an external attack or a logging attack could pose to our pipeline. So the entire workflow, the purpose is to present Databricks as a single dimension solution for not only implementing an entire pipeline that covers an end-to-end solution, but to see how within the platform of Databricks we can add an agent. The agent would be an assistant, would serve as an assistant to the SOC analyst, and the agent would help the SOC analyst in determining the attacks that our pipeline could face. So these attacks could be sort of prompt injection attacks, or some like memory leaks, some sort of memory leaks that our fraud level pipeline could face. So that is where, if we talk about you see the overall structure, we have the Databricks platform, right? And we have the network logs that are actually coming from the data. And then we have the ML model prediction on network threats. So we are seeing the network logs in a continuous manner. And what we are doing is that we are trying to predict the network threat using the ML modeling. So this could have been implemented by AI, but there is no need for it as of now. We have to explore the ML capabilities provided by the Databricks using MLflow. So then we proceed. We have an AI agent out there. So the purpose of AI agent is to use that serving MLflow model that we have created, and then actually summarize a thread that could potentially be in our network logs. So essentially, we have established our groundwork or baseline on a traditional classification ML prediction model, and then we are creating using the AI just to facilitate ourselves, so that our SOC analysts could have sort of a AI assistant to him that would help him diagnose these network logs. And then after that we proceed to the alerts generation. And once we have these alerts generated, we see those alerts, and we may as well, sort of give an immediate warning depending upon the severity of that alert, or depending upon the type of attack that we are facing in our network logs. And then we see the alert, and finally we update our AI agent and see how it actually recommended it. So the important thing right here is to see the false positive and false negative as well. So we have to make sure that our AI agent is not wrongly categorizing a network log that was actually a threat or an attack, and it should not wrongly classify it as a standard normalized data, or a data that is up to the metrics that we have set. So the purpose of using Databricks is simply to have a single entire dynamic platform that not only facilitates our data engineers who are working with the network logs, but also ML engineers or who are going to be implementing the foundational baseline ML predictor for it, and finally the AI agents. The reason for using Databricks and the actual capability of Databricks is that it provides this it facilitates not only our ML workers, but also like everyone in our code in our team. So that is the overall AI powered SOC with Databricks, and we are going to have a detailed look in it and see how these things are operated on the platform of Databricks, which is the single source of truth once again for us. And finally, we also have a demo out there. We'll be showing the entire implementation for our sample pipeline, and we could use it to to help our team basically. So moving on to the next slide. Yeah, so why real-time AI agents actually matter? So as you can see, we have a lot of data right now. The modern world is full of data, and with the increase in the utilization of AI agents and the chatbots out there, the data that we have collected and the augmented data is also increasing. Similarly, we have for a lot of pipelines and for a lot of workloads, we have a data that is continuous and it is streaming, or it is streaming maybe on a triggered base, maybe it is streamed as a batch, maybe it is a continuous stream. So as you can see, if we have a sort of, if we are dealing with the case study that is specifically having continuous amount of data, and if our pipeline is not secured enough, so that provides the opportunity to a lot of threats. We can have a continuous SQL injection attack, we can have a DDoS attack scheduled at regular intervals, and so on and so forth. Similarly, the thing is humans alone can't keep up with the complexity and scale. So we know that an AI is capable of comprehending things on a much faster level compared to a standard human. So if we have an SOC analyst who has, let's suppose, who has reports out there, and he has to read all the reports thoroughly and then provide a documentation or sort of feedback to the implementation, feedback to improve the overall security. So that takes quite much of time, right? But that is where we utilize AI. So actually, we can actually skim through quite a lot of data in a minimal amount of time. So the complexity, even with more or more, even with attacks getting more or more complex or threats being more and more poisonous, the scaling is actually something that is difficult for a single sort of person to handle. So that is where AI comes in as its assistant. Once again, the final decision would always be made by humans, but AI assistants are there to facilitate that decision making. So now what AI agent does is instant pattern recognition. Yeah, the way it works is obviously we know how they instantly recognize the patterns and summarize. So if we have a series of attacks that are of the same nature and they are at regular intervals, let's say, our AI, instead of a manual person, our AI agent would obviously be able to quickly interpret that and sort of trigger an alert to it that we have an attack. It is of a certain type. It is a DDoS attack, let's say, what it is trying to do, and on how much of a regular interval is it happening. So that is where the overall agents work. And finally, if we talk about the final flow, we have a data and an AI agent and then a decision making. The decision making at the end would finally be approved by a human, which is our SOC analyst. So if we look at the workflow out there, we see that we have our network logs that are coming in. We have our ML model that is predicting the network logs, and we have an LLM that is going to reason those. And finally, our SOC analyst is going to be the final source of decision making. So now, if we look at the bottom line below, there is this Databricks plus Mosaic AI agents. So what is Mosaic AI, right? We have talked about Databricks as a single source of platform, right? But what is Mosaic AI and why are we using it? Or why is like the Databricks so focusing more on the Mosaic AI? So Mosaic AI is your model management, not sort of a model manager for the models out there that you have deployed on Databricks. So Mosaic AI is like covers all of your models, and it covers their endpoints. It provides the security for those models. The version control for those models is also maintained by Mosaic AI, and all in all, it is your manager for your model that is available on Databricks. Anything any change you do to your model, anything you want to add to your model, you always have to bypass to using Mosaic AI. Mosaic AI is not like a thing or an agent itself. It is the set of capabilities that Databricks has provided us thanks to Mosaic. It is the set of AI capabilities that database that basically cover our models governance, models logging, everything. These set of capabilities, we term it as Mosaic AI, right? So that is obviously going to be a critical component in the overall implementation, since our models and the serving models and the AI agent would always be governed and monitored by Mosaic AI. So moving on to the next slide. So foundations. So now the Databricks foundations and the foundation that are part of this project, we have a few foundations: the Lakeflow, Mosaic AI, and MLflow 3.0. That actually basically one we have a pure data terminology, then we have a pure generative AI, and then we have a classical machine learning problem. So if we talk about the foundations, these are foundations on which the Databricks environment is being standing. So we have Lakehouse, that is a unified data and AI platform. It provides us the governance, the asset compliance, and in the delta formatting, everything, a single source of truth, along with the Unity catalog governance feature. So that is where the Lakehouse is standing. So the Lakehouse is your single data warehouse or the single storage layer within the platform of Databricks, that you can basically have multiple changes made to a single sort of table. For example, using the Lakehouse, we could provide relevant permissions, and we could also apply column masking, filtering. So all of these come under Lakehouse. And then we proceed to the Lakeflow. Once we have an entire workflow created, the next thing is to streamline that workflow, right? And for that, we need pipelines, and how these pipelines are managed in Databricks through Lakeflow, and agent breaks for summarization and decisioning using Mosaic AI. So as I mentioned, Mosaic AI is the one handling agentic work within Databricks, and so our summarization, alerts, and threads would always be handled by Mosaic AI. And finally, we have MLflow 3.0 that is there to basically track and deploy the threat detection model, the prediction model that we have detected. MLflow is going to be the one that is responsible for maintaining that model. So now moving on to the next slide. Why SOC is a perfect agent workload. So as I mentioned below, then what is the need for the SOC perfect agent, right? So I think we have covered this quite a lot, but once again, we have a lot of data coming in, right? Constant data, and the data that is now and quite a lot of or significant amount of that data will always be the one, or that pipeline will always be the one that is handled by a vibe coder. That is the reality now. We are actually dealing with vibe coders, right? So the data of the pipeline they have created will always be prone to huge amount of threats. And for cybersecurity, that is why agent is a perfect SOC agent is a perfect workload, because if we have, let's say, continuous amount of data, we need continuous monitoring on it, right? And for that continuous monitoring, we have high volume and repetitive tasks. And for that, correspondingly, for this much amount of data, let's suppose our data is maybe in terabytes or petabytes of memory, right? And we need a sort of automation agent that is going to continuously monitor those network alerts based on the classification that we did. So that is where AI agent bot comes in, because of its fast response, the high volume task that it is able to handle, adaptation, since LLM is always going to consider the context. So the crucial the context, the greater the alert would be. And similarly, once we have the alerts, we can then integrate it with further platforms. So we can use our agent to then integrate with some sort of uh, real-time application, or and let's suppose a standard email generation out there, or sort of a planner out there that could design our networks in a more efficient manner. And finally, since we have a lot of data coming in, we need a continuous monitoring for it. So single human being won't be the best choice, right? To continuously monitor all the entire data. So that is why SOC is a perfect sort of an example to understand the need of agents the cause of how basically it all started with AI, right? The intensive use of AI by web coders, that is the one that actually caused the network threats, right? So it started with AI, but we have to use AI to basically cover it as well. So that is how the agent workload is a perfect example for this case study. So now moving on to the next slide. So SOC deep dives and challenges and data. So what are the challenges that an SOC analyst usually face? Let's suppose I am a person who is an SOC analyst, and I am responsible for managing the challenges, and I have to make sure the network alerts are there, and there are various different things that we could face, right? So what have to look for carefully, specifically in an attack, is the alert overload. So there may be a lot of attacks out there, and the alert system might not be properly operational, or I alone might not be able to handle the alert overload. Similarly, false positive, with this huge amount of data that I am getting, so I am not able to, maybe I'm not able to skim through all of the data properly, and that could cause false positive. And even if a single attack threat that is left unattended could cause huge amount of problems for us. Once again, complex environments are there. The traditional methods have complex environments. Their scalability is like very redundant and a difficult process in itself, and they have slow responses. So with this amount of data, with the huge amount of data that we are getting, we need a system that is actually being able to handle a large amount of responses at a faster rate. So that is why the agent is the one that is going to be the one provider for us. And finally, we have the skill shortage once again. With as all the challenges we face, skill shortage is something that is going to be problematic for us. So objectives once again is to handle all these, including the AI driven SOC detection, then summarization, then alerting, then recommendations, and highlighting the threat parameters. So that is how overall the solution that is the objectives that our solution is going to cover. So now proceeding. Dataset, yeah. So let's just quickly skim through the dataset overview. So we have a source dataset that is the University of New South Wales, and it is a network traffic dataset. Once again, we have continuous monitoring of the data, and for that data, we have the network logs that are continuously appearing. So what we would be interested in a few details. So it has like a variety of columns in it. So 49 columns out there. So you have abundant amount of data to deal with, and similarly there are different sort of attacks that could be posed, including a DDoS, prompt injection, even SQL injection, or similar memory leakage or byte attack. So all of these things could be implemented on this Cyberport dataset. And it has features. If we talk about few of them, it is IP address, there are ports, there are protocols, services, timestamps, packet info, and flows. So these are some of the features that we have discussed. And if you see, all of these features are there that are very essential to network security for a certain pipeline. If any of these features is breached by any sort of attack, they would be triggered, and that would be problematic for us. Similarly, flow features, if we talk about flow features, that are duration and packet bytes, which is self-explanatory. And basic features are like source IP and destination IP protocol. So finally, if content features, TCP, UDP flags, the payload characteristics are obviously important for sort of SQL injection tasks or sort of tasks that are fed through an API call. And finally, the traffic label, we have the normal DDoS, reconnaissance type attacks, and etc. So this is the overall view of the data set. And if we move to the next slide. Now, so that was pretty much it for all the overall. I think I have like gained much more attention from you guys, and I have bored you enough with the overall dialogues and explanation. So now I'll be handing over to Muhammad Tayyab, the demo. He will be describing the demo, which is basically two parts: the threat detection and then the agent implementation. So Tayyab, back to you.
Okay, thanks Muaz Ahmed for this exceptional presentation. So, hello everybody. So, I prepared the demo for this webinar. So, as was stated, there is two parts. The part one is threat detection pipeline, and the other part is alert summarizations and recommendations. So, in the first part, we basically ingest our data, and we will basically pre-process all the entire data, and then we will apply feature engineering techniques like categorical, numeric, and scaling the vectors. So then we will use the logistic regression models for the training the model, and then we will showing you how to use MLflow for model registration and model serving points. So let's move on to the next slide, in which we will talk about the part two for this demo. So in this, we will basically some streaming the data and use that data for summarize the results using Mosaic AI agent, and we will basically generate the recommendations that generated by uh, our AI agent. So after that, the output will be covered like the alert card with details, action steps, and the recommendations. So if we are talking about the architecture diagram that we designed for this webinar, so as you can see, we have different file formats of the UNSW dataset. So in which we will basically read all the data and store it into our data tables, and then ingest into our Databricks pipeline. So we are using the medallion architecture, in which we are using bronze, silver, and gold layer for storing the data step by step. So in the bronze layer, we dump all the raw data, and when we all the pre-processed data, like we we applied cleansing, delete duplicate rows, and filling the NA values. Then we will store the clean and most refined form of data in golden table, in golden layer. Then we will implement a machine learning model. As I stated, we use the logistic regression. So we prepared the data for this model. We use label encoders to categorize the categorical variables into numerical format, and then we basically applied MLflow for model serving and registering the endpoints. When MLflow basically registered the model's endpoint, so the new network logs data comes in into the feeding into the logistic regression models, and that model predicts the output, and the AI agent will summarize the output and interpret the results to the end users. So finally, we have to generate alerts and recommendations. So let's move on to the Databricks environment to showcase how we implement this. So let's move on to this section.
Tayyab, could you hold on for architecture diagram for a while? I just wanted to add a few things to it.
Yeah, sure. Hmm.
Yeah, could you like slideshow, open the slideshow for it?
Did you see that?
No, I think that's fine. The previous part, the previous version is fine.
Hmm.
So guys, sorry for that interruption. I just wanted to highlight a few of the capabilities. So the governance for the data lake out there is handled by entirely by Unity Catalog. And the governance for the model is handled by Mosaic AI. So these two components, they play a pivotal role. So we have an ingestion pipeline that covers the data. Once the data is there, that is governed properly and ingested in delta formats, and the entire thing is managed by Unity Catalog. Once it is done, the ingestion part is complete, then we proceed to the model management. The model, initial model, we have, once again, we have two types of models, right? We have an AI model, classical AI model, and then the agent on it, on top of it, the layer of it. So the entire agent, the entire ML model is managed by MLflow, and it is served as a serving point. Using the MLflow capabilities, we register the model into the artifacts and logs, so that we don't need to go over the model again and again unless or until some new type of implementation comes around. So MLflow saves that in the saved logs, and once we have that model stored in the saved logs, the AI agent would be using the predictions and the logs from that model to basically alert and summarize the network threats. So finally, the AI agent itself, the configurations for the AI agent would be then stored, would be then governed, and this entire flow would be governed by Mosaic AI. So that is something which I wanted to highlight specifically, how the Unity catalog model data management and how the Mosaic AI model management differs. And you will see that the storage in the Unity catalog in the demo as well. So that is just a heads up that I wanted to give. Thank you. Tayyip, could you please proceed?
Yeah, sure. Thank you, Muaz Ahmed, for adding this. So yeah, so when you move on to the Databricks workspace, so in this you can see there is two panes, the left pane and the right pane. So we are using basically Azure Databricks. So in this you can see the workspace, catalogs, jobs and pipelines, and the compute section. So you can, if you want to create a cluster, so you can simply create compute and you can create the cluster. So if you want to create the notebook, so simply click on the workspace and you can create the notebooks for this. So for this demo, we created the notebooks. And another thing, there is the catalog. So if you want to create the catalog, so simply click on the catalog button. And for this webinar, we have a network data catalog. So when we click on it, so you can see this is the network data catalog, and all the catalog mentioned by managed by the Unity catalog. And if you click on to the detail section, so you can see there is the metastore ID, created at, created by, and the advanced option is the predictive optimizations is enabled in it. So if you want to give you the permission, so you can simply click on the permissions tab, and now you can see the only browse permissions is assigned to all the users. So this is the basically catalog of this, and in which we have different types of tables, the network data, all data, and all this stuff. And the one other one is the save model. So we are using MLflow to register our model in the Unity catalog, and we will talk about later on it. So let's start with the ingestion pipeline. So in this you have to see we have three notebooks. In the first notebook we ingest the data into our pipeline, and then the next notebook identifies, we basically train our model, and the third one is we agentic attack detection. Okay, so in this notebook we simply read the data from the database file system, and we infer the schema in which we will specifically mention the separator we use is telemeter header is the first row, and we are also inferring the schema. So this is the original data set that we load in. As you can see, we have 5,911 rows. And if we want to see the columns of this data frame, so as the Moz stated, we have 49 columns, and the column name is the source IP, source port, destination IP, and the destination port. Other than column is that is type is nominal from protocols, states, and the services. And the target columns that we basically deal with these attack category, and we have different types of categories in this data set, like buzzers, analysis, backdoors, TOS, exploits, and etc. Also we have a label column in it, so we are using the supervised machine learning. So if there is any attack predicted, so the label is 1, and if there is not attack, so the label is 0. So basically here is how we can ingest the data into our Delta Lake. So, so let's move on to the next notebook in which we trained our model. So as you can see, the data is basically ingested in our uh, in Delta Lake, and you can see the uh, sample of our data frame in which have source IP, destination IP, and all this stuff. And you can, if you can see, the attack category is null because the label is 0. When label is 1, the attack category is assigned. So now we will fix this into our data set. So here is the pipeline that we are basically, let me click. Okay. So in this, as you can see, we have fill NA values as we have tag category is most of the nulls because there is label is 0. So we will assign the normal on it, and there is some typo errors we fix on it. There is some columns that they're required to be treated as numeric, so we will change the data types, and some columns required as a binary type, so we will set the binary. Okay, as I stated earlier, there are many columns like proto, state, and service that is categorical columns. So we need to categorize or encoding these columns before feeding into our model. So for this, we are using the label encoder technique or one hot encoder techniques to transfer these columns uh, into numeric columns. So then we will drop some unnecessary columns that is not using in the training part. So we are dropping these columns in which like source IP, destination IP, and all these. Now we are applying on the train test split on this data frame. So we have the ratio 80 and 20. So 80% data is training set, and the 20% data is our test set. Then we will apply it on standard scalar technique to standardize the features. And now we will fit on the logistic regression model. So after that, we calculate the accuracy and the classification report that the models returns us. And then we created the save objects as a make directory. So in which we will store basically the models and the artifacts that are using JSON lib library. So that's we are using this because we don't need to train our model again and again. So we will using only these save dump files. So when we scroll down, you can see the model artifacts here. So as you can see, the accuracy of this model is 0.98%. And okay, this is the snippet that we will using to register this model, uh, machine learning model into MLflow. So in this, we are passing the basically model name, SK model, artifact path is artifact, and the model's name, and the path that we are basically saving our model. So we are saving that model into Unity catalog, and we will see how this model is registered in Unity catalog. And we are now saving the log artifacts in this path using artifact pre-processing. So So let's call this model and see how this model returns. So basically, this is the sample. Sample. You have a sample record, and we will feed this into our machine learning model. So when we will feed this into our model, so this is predicted basically exploit attack, and the probability score is 0.4322. So when we click on to the catalog button and click onto the network data that we created earlier. So as you can see, there is the model section that we registered our model in Unity catalog. So when you click on it, you can see there is the different versions that we registered that model by using the Mosaic AI. So with the help of Mosaic AI, we can store all the versions that we trained our model, and that reflects here. And if you scroll down, you can see the activity logs. So you can see there is the timestamp with the versions, and this version is basically saved at this timestamp, and the logs also here. If you want to check if your model is registered or not, you can simply go AI and ML section, and there is the model column. So when you click on to the model tab, so as you can see, this is the network inference model that we saved earlier. So when you click on it, and you can see this is the model registered. So if you want to serve that model for further use, so simply click on use model for inference button. So I already did that, so this button is not enabled for this model. When you click on it, you will go to the serving tab, and as you can see, your model is here as serving endpoints. When you click on it, you can simply copy the endpoints of that model and use wherever you can. So now if when you click on the serve model, it takes 1 to 2 minutes to state in ready, right? So let's go back to the agent notebook, in which where we will define our agent to. Okay, so in this notebook, we basically call the model, pass the Databricks token, and we will using OpenAI client to register the AI agent. So we applied all the pre-processing on the incoming new logs data, and you can see we are using the Databricks Meta Llama model using by the chat completion models, and where we can pass the prompts and the roles that the AI agent will act accordingly. So when you run on this, so you can see there is the basic agent's output. So we will feed the source IP, destination IP, and all this stuff into our model. So models return the predicted attack and the confidence. And there is the summary that the AI agent powered by Mosaic AI will generate the summary. So as you can see, the predicted threat is the predictive model indicates a potential exploit attack with a confidence level of 73.12%. And exploit attacks typically involve taking advantage. So this is the basically summarizations that generated by our agent, and this is the recommendations that we can do after this. So you can see the monitor network traffic, verify software updates, and implement additional security measures. So these are the basically recommendations that the AI agent will pass through. So if you talk about the flow of these pipelines and how we can run this pipeline in one go, so you can simply click on to the jobs and pipelines button. So we already created the jobs for running this pipeline in one go. So I already created the network threat detection pipeline. So when I click on it, so as you can see, there is multiple times pipelines running. So when you click onto the last, so yeah, so these three notebooks that I showed earlier is basically shown here, and all the notebooks is running accurately. So you can basically create the pipelines and jobs to run your entire code in one flow. So as you can see, there is the duration. So these pipelines take 7 minutes and 7 seconds to complete, and the status is succeeded. Or we are using these compute informations like driver we are using for this webinar demo, the standard DS3 V2, uh, and these. we are using DS3 family clusters. So here's we can create the pipeline and run all the flow. Okay. So
Thank you, Theo, for that interesting and very sort of interactive demo. Even I could lost in all of the details. So we have, guys, a lot of questions coming in that I'd like to, you know, present an answer to. But before that, I'd like to get the summary. Dave, could you change the view to previous one because like it is good.
yep,
So if we talk about the summary, once again we have the foundation that is the lake flow, and the lake flow is being incorporated to handle the entire data ingestion process. The Mosaic AI automates the threat level detection and response. So the ML flow basically that should have been above there. The ML flow is there to basically predict the threats out there. The threats are being predicted by classical ML model out there, and then the agent based on Mosaic AI is being used to not only create a summarization, right, but also recommendations for it. If I am correct, right, there.
yep,
Sounds good. So, guys, we have a lot of questions coming in, and we'd like to answer all of those questions. So there is one question: what did we classify earlier, and where the training data come from? Did we classify it as an attack or not? So the training data out there, they basically, as we mentioned, it was from the University of New Northwestern South Wales, NSW, sorry, and the basically the training data was part of an ingestion pipeline. The data was initially stored in Azure Delta Lake storage, and from there we got the data through the ingestion pipeline into our Databricks platform and stored it in a Unity catalog table. Correspondingly, did we classify it as an attack or not? So the training data was basically logistic regression model that is implemented, and that continuously classifies the data. So yes, we are actually not classifying but predicting, sort of. Are creating a prediction on an attack. So the next thing, the next question is: are the agent ready to use, so we don't need to code them? So that is an interesting thing. That is, let me tell you one interesting thing about Databricks itself. So the Databricks has both open source or the closed source models out there. So the Databricks has these built-in models that are already there. You don't need an external API for an OpenAI model or some other open source model out there like Llama. We use the Databricks client to handle all these, and the Databricks client is dictated but for the code of an agent and the way a certain agent will behave, that will always be have to be coded, right? So the next question is: the next agent Llama will be the one predicted threat and use their log to do something recommendation, or is, yeah, exactly, we don't use the agent to basically classify it. We have a foundational model that is an MLflow model for classification slash prediction, and the agent will be used to finally summarize them as well. So that was the overall thing. And I think we have a bundle of questions, other questions coming in as well. But I'd like to move on since we are a bit short on time. So I'd like to move on to the keynotes for this presentation. So guys, thank you so much for attending. And but the question arises is: you have a platform that is Databricks, right? We know that it is very capable. And what we plan to do, what as a client customer, what you need is you need a proper guidance and consultation for in order to implement your use cases, in order to make sure that you are not spending a lot of cost on Databricks, because it can be a double-edged sword. So that this is where Royal Cyber comes in as your as the Databricks consultant for you. We are there. We have been in the game for 20 plus years, and we have seen the platform of Databricks evolve. We are a significant client partner with Databricks as well. So Royal Cyber will be the one that is going to provide you with optimal solutions to not only your data and data problems, ML problems, and generative AI problems. So we offer a complete package for the entire implementation of your database related solutions. You want migration related solutions, that could implement it by us as well. So we have proper and thorough professional, and we see a lot of you out there, and we hope that a lot of you would reach out to us for their for not only the solution but maybe a general discussion about their potential solutions, or maybe somebody has sort of a network attack in their mind and they would like us to help them with that. So that could be made possible as well. So that is pretty much it from my side. And one last thing about the demo itself, the demo, and since obviously we could not train an entire model in this short demo, the demo and its proper slides and notebooks, they could be provided in terms of demand based. So if you feel like you want to implement this demo by yourself, or if you want to explore this demo too, and mold it to a use case of your choice, you could reach out to us at customer support at royalcyber.com, and we'll be happy to not only consult you but also help you with your projects as well. So I think moving on to the last slide, that is just a sort of formality for us as of now. We have had a lot of your time, and I believe that we were able to at least, I am hopeful that we were able to at least make at least one person understand what the overall agenda of this project and implementation was. So that was pretty much it from my side. I am Muaz Ahmed, and thank you so much for all joining, and we'll see you there in the next webinar. Thank you, guys.